I was 26 years old. I was the guy they came to when the calculations got strange. The expert who could look at any answer and tell you why it had to come out that way. And I was about to sit in a room with Enrico Fermi, the man who built the first nuclear reactor, the Nobel Prize winner, and the physicist they called the Pope because he was never wrong. I was about to watch him see through a problem instantly that I had struggled with for weeks. Los Alamos, 1944. The most secret place on Earth. We were building the atomic bomb. And I was about to find out I wasn't as good as I thought I was. Let me tell you how that happened. 2 years earlier, I was a graduate student at Princeton. I hadn't even finished my thesis when Bob Wilson walked into my room and told me about a secret project. They were trying to separate uranium isotopes. They were trying to build a weapon that could end the war. I said no. Then I thought about it for 3 minutes. The Germans had Hitler. The possibility that they would build this bomb before we did was terrifying. So I went to the meeting at 3 o'clock. Within a year, I was at Los Alamos in the mountains of New Mexico. I was in the theoretical division, working under Hans Bethe. Bethe was a giant. He had written the famous review articles on nuclear physics that I had studied as an undergraduate at MIT, and somehow I ended up working directly with him. Here is how that happened. When I arrived, all the big shots happened to be away. Bethe needed someone to talk to, someone to push his ideas against. He came into my little office and started explaining something. I said, no, you are crazy, it will go like this. He said, just a moment, and explained why he was not crazy. I was crazy. And we went back and forth like that. You see, I had one advantage. I never knew who I was talking to. When I hear about physics, I just think about physics. If the idea looks lousy, I say it looks lousy. If it looks good, I say it looks good. I do not care if you are a Nobel Prize winner or a graduate student. Bethe liked that. He made me a group leader with 4 people under me. I developed a reputation. People would come to me with their calculations, and I could usually see why the answer came out the way it did. Not always by doing the math, but by understanding the physics underneath. I had a feel for it, or so I thought. In the middle of all this, there was a problem I was working on. It involved mixing uranium and hydrogen, something called uranium hydride. The calculations were enormously complicated, with multiple variables and different neutron energies all tangled together. I did the calculations. I got the results. But for once, I could not explain them. The numbers made sense mathematically, but I could not see why. I could not find the simple physical picture underneath. It bothered me. Then Fermi came to visit. Enrico Fermi had won the Nobel Prize in 1938 for his work on neutrons and radioactivity. He had fled Mussolini's Italy and come to America. In December 1942, in a squash court underneath the football stadium at the University of Chicago, he had built the world's first nuclear reactor. He was the first person to create a self-sustaining chain reaction. He was, quite simply, one of the greatest physicists alive. Fermi was based in Chicago, but he came down to Los Alamos from time to time to consult, to help us if we had problems. This was one of those visits. We had a meeting. There were maybe 8 or 10 people in the room. Fermi wanted to know about the uranium hydride work, so I started to describe my results. He stopped me. He said, "Wait, before you tell me the result, let me think." And then he began to reason out loud. "It's going to come out like this," he said. "And it's going to come out like this because of so-and-so." He was right. Not approximately right. Exactly right. He predicted my results, and then he explained them with a perfectly obvious physical picture that I had completely missed. He was doing what I was supposed to be good at. 10 times better. I just sat there. It was the first time in my scientific life that I had felt truly outclassed. Not in mathematics, not in technical skill, but in exactly the thing I thought was my special gift, my ability to see the physics. That was quite a lesson. Now, here is the thing about Fermi that I came to understand later. He was not just brilliant at theory. He was also brilliant at experiments. Most physicists are one or the other. The theorists work with equations. The experimentalists work with equipment. Fermi was both. He could derive the formula, and then he could go into the laboratory and build the apparatus to test it. That is why he could see physics so clearly. He understood it from every angle. After that humbling experience, I spent more time around Fermi whenever I could. He was a warm man, generous with his ideas. His wife would make us dinner. We had parties at his home. One time he came up to me and said, "Hey Feynman, I've been reading this technical report of yours. I wonder why you bothered to print it. Because couldn't even a child see that this result has to come out this way?" I said, "Yes, if that child's name was Enrico Fermi." "No," he said, "even an ordinary child." It turned out, in the end, it wasn't as obvious as he thought. But that was how he talked. Everything seemed simple to him, because he could see through to the heart of it. What I learned from Fermi was this: there was always another level. If you're finding this valuable, subscribe. I tell the real stories of how breakthroughs actually happen. I had thought I was good at intuition because I was better than most of the people around me. But Fermi showed me that intuition wasn't a fixed thing. It was something you could develop, deepen, refine. The more you understood, the more clearly you could see. It changed how I approached physics for the rest of my life. Instead of being satisfied when I got the right answer, I would ask myself, can I see why it has to be this way? Can I explain it without the mathematics? Can I find the simple picture underneath? That's what Fermi did, naturally. And watching him do it showed me what was possible. In September 1944, Fermi moved to Los Alamos permanently. Oppenheimer made him an associate director and put him in charge of F Division, named after him. We saw more of each other after that. Then came July 16, 1945, the Trinity test, the first atomic bomb. We were out in the desert, 20 miles from the blast site. They gave us dark glasses to protect our eyes, but I knew that bright light can't hurt your eyes. Only ultraviolet can, so I got behind a truck windshield because glass blocks ultraviolet, and I watched the whole thing directly. That tremendous flash, so bright I ducked. Then I looked back up and saw this white light changing to yellow, then to orange. The clouds formed and disappeared as the shockwave compressed and expanded the air. Finally, a great ball of orange rising and billowing, getting black around the edges. It took about a minute. Then, after about a minute and a half, the sound arrived. This tremendous bang, and then a rumble like thunder. That sound released everybody. We had all been watching in silence, but when we heard it, we knew it had really worked. Fermi was there too, 10 miles closer to the blast, at base camp. He had his own way of measuring things. He dropped little strips of paper and watched how far the blast wave carried them. Then he paced off the distance and calculated the yield. He estimated 10 kilotons. The actual yield was about 18 kilotons. Not bad for a man with some paper strips in his feet. That was Fermi. He could estimate anything. He was famous for what became known as Fermi problems. How many piano tuners are there in Chicago? How many atoms are in the human body? He would break the problem down, make rough estimates for each part, and arrive at an answer that was remarkably close to the truth. It wasn't magic. It was a way of thinking, a discipline of making the unknown knowable through careful approximation. Years later, when I was teaching at Caltech, I tried to pass this on to my students. I would tell them, you have to develop physical intuition. You have to be able to estimate things, to see what's happening without getting lost in the mathematics. But I always remembered that I learned this lesson the hard way, by meeting someone who did it better than I could imagine. Here's what I want you to understand. I never felt diminished by that experience with Fermi. I felt enlarged because he showed me that the ceiling was higher than I thought, that there was more to reach for. Some people, when they meet someone more talented, feel defeated. They think, I'll never be that good, so why try? But that's the wrong way to see it. The right way is to say, look how far it's possible to go. Look what the human mind can do. And then you get to work. I never became Fermi, but meeting him made me a better physicist. It gave me a target to aim for. It showed me what deep understanding really looked like. He died in 1954, just 9 years after the war ended. Stomach cancer. He was only 53. I went on to do my own work. The diagrams that carry my name. The Nobel Prize. The lectures that I hope help students see physics the way I learned to see it. But whenever I managed to explain something in a simple physical way, whenever I could see through the mathematics to the reality underneath, I thought of that day at Los Alamos. That room with 8 or 10 people in it. That moment when Fermi said, "Wait, let me think," and then proceeded to do what I did. 10 times better. It was humbling. It was inspiring. And it was exactly what I needed. Because that's how you grow. Not by being the smartest person in the room, but by finding the rooms where you're not. I was Richard Feynman. And the greatest lesson I ever learned came from Enrico Fermi. If these stories resonate with you, subscribe and join me for the next one.